Welcome back to Pharma-info with Shubhashish. Now today's topic is Claisen-Schmidt condensation. This condensation reaction can also be termed as cross-aldol condensation, right? Chalo. So aldol, we all know that it is basically an affair of aldehydes, right? And which aldehydes? The aldehydes which are having what? Alpha hydrogen, right? So the same thing here also we are going to bring, right? So let's see that here we are basically dealing with what? The aldehydes or ketone, right, which must have in them ketones which must have in them alpha hydrogen. That means it is the alpha hydrogen containing aldehyde or ketones that is found to be one of the essential requirement, what we can say, right? So this is found to be the first one, right? And the other one is found to be non-alpha hydrogen containing aldehydes, right? This is found to be the other requirement, right? Containing aldehydes. Fine. So these two are the prime requirements, and only thing is that we need to merge them, right? We need to condense them, right? Chalo. So now let's do one thing, okay? On the basis of this the type of aldehydes, let us just create one compounds, right? Okay. If we if we are in the hunt of getting this non-alpha hydrogen containing aldehydes, right? So the first preference should be given to an aromatic aldehyde. It is an aromatic aldehyde, okay? आँख बंद करके, this is the one in which no alpha hydrogen is traceable, right? Fine. So this is the first, this is the the one of the requirements, right? So this is found to be the one in which no alpha hydrogen is there, because if I just see the next carbon is not having any alpha hydrogen, not even a single hydrogen is there. Fine. So that is why we can say this is an example of non-alpha hydrogen containing aldehyde, right? At the same time we have to take the other reagent, that is your alpha hydrogen containing aldehyde or ketones, and they are basically of aliphatic origin. Fine. Chalo. So let's do one thing. Let us take one simple aldehyde, like you can take like CH3 C double bond O, right? And if I just put here R, if I just put R equals to H, it is acetaldehyde. If I put R equals to CH3, it is acetone. Fine. Because here two provisions are there, right? Either aldehydes or ketones, okay, can be the choice, right? Choice of other reagent. Fine. And that must be of aliphatic origin. Fine. The same thing here also I have written. So we have an non-alpha hydrogen containing aldehydes, and I just want to condense this with alpha hydrogen containing either aldehyde or ketone, right? So what is the product that we are going to get actually? Okay, fine. Now once the reaction is on, right, let me tell you one thing. Here we need to take what? We need to take 10% NaOH. That is found to be another essential requirement, right? Now make sure that it must always be 10%, right? If you are taking a concentrated sodium hydroxide or a strong base, and that too a concentrated one, so that time what will happen, instead of getting cross-aldol condensation, no, we are going to the Cannizzaro reaction will occur. Fine. The Cannizzaro reaction will occur. Fine. But here we have restricted what the strength within 10% only, or to 10% only. Fine. So that means it is the 10% NaOH that is basically used in the reactor. Okay, fine. And here you need to at the same time, okay, fine, you can just conduct this reaction in ambient temperature, that means at room temperature, or just slightly more than room temperature. To be more precise, you just keep the temperature 30 degrees centigrade. Fine. So what will happen? What is expected here? So here the product which is expected over here, since it's a condensation, right? Since it's a condensation, what will happen? There is a formation of this kind of stuff. Yeah, CH, then we have a C double bond O. I'm just putting here R, right? It is your choice whether you have taken R as H or CH3. This is the product that is getting formed, right? Fine. So what is the product all about, right? How this can be named? What could be the general name of this particular compound? See. So this is found to be the parent functional group, right? Functional group PFG, fine. And the immediate neighbor of the parent functional group should be given the alpha. And the next one is found to be the beta. Now we have a double bond between alpha and beta. So can we call it as alpha beta unsaturated carbonyl compounds? That is getting formed, right? That is getting formed actually, fine. So now let us just sum it up, fine. So it is an aromatic aldehyde while being reacted with an alpha hydrogen containing aldehyde or ketone in presence of 10% NaOH, okay, with ambient temperature. What will happen? There is a formation of, through condensation, there is a formation of alpha beta unsaturated carbonyl compounds. I can write it over here, alpha beta unsaturated because this is the location where unsaturation is, clearly visible. Fine. So alpha beta unsaturated carbonyl compounds. It can be an aldehyde, it can be a ketone, right? Okay, fine. Depending on the starting material which we have opted. Fine. Carbonyl compound. Fine. Chalo. So this is all about here the general reaction. The general reaction of what? General reaction of Claisen-Schmidt condensation, right? Now let's move on to the reaction mechanism, right? Now let's move on to the reaction mechanism. Chalo. So initially what will happen? Let us do one thing. Let us just, stick to, let us just take on these things. Initially, so these two are the initial requirement, right? Okay. Now initially what will happen? There must be a generation on in step 1. What we can see, what we are going to see is in step 1, there must be a generation of what? A carbon ion, right? Chalo. If our starting material is found to be the alpha hydrogen ketone, alpha hydrogen containing ketone, I can just write it like this, because just to indicate, just to show, or that yes, that this is found to be the alpha hydrogen, right? And which can be which can be extracted. Fine. So how this can be extracted? Fine. How this can be extracted? As I mentioned over here, 10% NaOH form is found to be another prime requirement. What we can say, it is the NaOH through which OH minus will get released. Yes or no? Fine. So OH minus will get released. So what this OH minus will do actually? The OH minus will try to hook up what? This H plus, right? So it is the H plus that is basically being hooked up by what? The OH minus. Fine. Now in this very process, what will happen? There is an elimination of water that is expected. Fine. And which ultimately leaves what? Or leaving behind what? An intermediate, a reactive intermediate in which a pair of electron is noticeable. Fine. Because it is through expulsion of H plus, what happened? This has become a carbon ion. Carbon ion. Fine. So carbon ion can behave as a nucleophile, what we can say. It can behave as a nucleophile, carbon ion, because there is an abundance of electron, and anything which can which is having an abundance of electron can serve as a, most of the times can serve as a what? Can serve as a source of electron, right? And thus can serve as a nucleophile, what we can say. Fine. Chalo. So this is found to be the nucleophile which is getting formed at the initial step or step 1. Fine. What next actually? Now let me tell you one thing. You can just put like this. It's a reversible reaction actually. Fine. Chalo. It's a reversible reaction. In reversible reaction, you are not supposed to put like this. Fine. Rather. Yeah. Fine. So what next actually? Once there is a formation of a carbon ion, what will happen? This carbon ion will target what? The other reagent, the other essential reagent, that is your aromatic aldehyde. Fine. Chalo. Now let's do one thing. Let us just bring what? The aromatic aldehyde. So this is your H5C6. I am talking about this phenyl ring. Fine. Let's do one thing. Let us project here like this. Fine. So this is found to be the benzaldehyde. Now just beside this, I am supposed to put what? I am supposed to put the carbon ion. And it is meant for what? It is meant for attacking what? The carbonyl carbon, because this is found to be the electron deficient center, right? So this charge can be given to this carbonyl carbon. Fine. Chalo. This carbonyl carbon, this charge can be given. Fine. Now the moment this charge has been given to this carbonyl carbon, what will happen to this pi bond? Definitely no longer it will stay here, right? Rather it will try to go on top. Fine. This is also a reversible reaction, what we can say, right? So now what next? H5C6, then C, not double bond O, rather O minus. Fine. We have a hydrogen here and followed by a CH2 and then C double bond O, and finally we have a CH3. Fine. Chalo. So this is okay, it's visible, I think. Fine. So this is the one that is getting formed, right? This is found to be the intermediate. So this is found to be the first reactive one. So we can just put we can just consider this as a intermediate one, right? Now once this intermediate one reacted to this non-alpha hydrogen containing aldehyde, so what happened? Intermediate 2 is getting formed, right? Intermediate 2 is getting formed, and this is how it looks. Fine. This is how it looks. Now what next actually? Okay, fine. So now the next is what? The next is obviously there's now what will happen? Now see what is expected. So we are not at the verge, rather what is expected? The expected outcome of this particular reaction is found to be, condensation is found to be alpha beta unsaturated aldehyde or ketone. Fine. Chalo. So up to what we are done? We are done up to this level. Fine. We are done up to this level, right? Chalo. So now what is expected? Since there is O minus, since there is an O minus, right? This O minus will try to grab what? H to get its stable form, right? Chalo. So if it is trying to get its stable form, what will happen? It has to interact with H2O. It has to interact with H2O, right? So what will happen as a result of this particular, aqueous accessibility, right? What will happen? This O minus turns to OH. Yes or no? This O minus turns to OH. Fine. And this is the one that has got formed, right? So we are one step behind, I think. Fine. So now, so here we have a phenyl, here we have a phenyl. Now, carbon, double bonded carbon. Fine. So what is expected? I want to, make this area, I want to make this particular area to be an unsaturated one, right? And it can only happen once water will go off, right? Once water will go off, then only it will happen. Otherwise, no question, right? No question. Fine. Chalo. अब होना क्या है? Now what next? Elimination of water. Fine. Elimination of water. चलो. तो elimination of water results in what? Elimination of water results in results in what? The formation of the double bond, right? Chalo. Now, okay. So here we have like this. Fine. Now still we have ample amount of sodium hydroxide here. Fine. So this hydroxide, what will it do actually? Okay. Now let's do one thing. Let us just put here OH minus. Fine. Chalo. So what this OH minus will do? This OH minus will try to snatch what? One hydrogen, right? From here, right? So this OH minus will try to snatch one hydrogen from here, right? And thus forming what? Water. And definitely will go off, right? Will go off. Chalo. So now according to that, if I just proceed in that way, so what is the other intermediate that is getting formed here? Still the hydroxyl is there with this particular carbon, right? Now we have a CH, we have minus, we have C double bond O, and then followed by a CH3. Fine. Chalo. So what next? Ab kya hona hai? Now what next? Now there is an elimination of OH minus, because once the OH minus will go off. Now how this OH minus will go off actually? Chalo. As there is a charge here, fine, because this proton went off, right? This proton went off, and it basically collaborated with this OH minus, right? In the form of water, it went off, right? And making this particular carbon to be an anion, right? Now this charge will no longer stay over here, rather it will try to come here. The moment this will try to come here, what will happen? The double bond is likely to be formed, and double bond will form once this OH minus will go off, right? Chalo. And then only it will acquire a stable form, right? Chalo. So now what will happen? If these things occur, then OH minus should go off, right? Then what is the final thing that can be written here? Like C, H, double bond CH, then C double bond O, followed by CH3. So thus we got what? So this is the parent functional group PFG, right? And the next neighbor is found to be the alpha position. This one is the beta position. Now what is happening? Now what is the product that has been formed here? Alpha beta unsaturated carbonyl compounds, right? That means the one which we talked earlier, right? While going through the reactions, there we observe that it is the alpha beta unsaturated carbonyl compound that is found to be the final product that we are basically expecting, right? So same thing here also. Through this mechanism, if I just follow this mechanism, this is how this alpha beta unsaturated carbonyl compound is getting formed, right? Fine. Let's do one thing. Let us just do a quick brush up, right? So how this reaction initiated, right? It was initiated with the expulsion of water, right? This base tried to snatch one proton from this alpha carbon, right? Thus forming a carbon ion, right? This carbon ion basically approached what? The carbonyl carbon of what? Non-alpha hydrogen containing aldehyde, right? Thus there is a formation of another anion here, fine. So what happened here? Now this anion, right? It has basically hooked up one proton from water, and thus forming what? A hydroxylated compound. This is a stable compound, fine. Now what happened? Just the immediate neighbor of this hydroxylated carbon is found to be another methylene, fine. So from here one hydrogen will be taken off, right? Taken off by OH minus, fine, and thus there is a removal of water molecule, fine. And once the hydrogen went off, what happened to this carbon? It turned to a anion again, fine. Now once it has turned into an anion, right, this particular charge will try to come here, right, to form a pi bond. The moment it's this senses, this hydroxyl senses that a particular bond is going to form over here. What will happen? This will try to leave this particular center, right? So this has happened over here. So with the elimination of OH minus, what happened? Our compound of interest, that is alpha beta unsaturated carbonyl compound produced, right? So this is how the entire process went on, right? Chalo. So now let's do one thing. Let us just see that, okay, I can just write here intermediate 3. We have a 4 over here, and this is found to be the final compound, FC. Fine. Chalo. So let me do one thing. Let me just project this one. Okay. Let me just project this one in this way so that you can at least refer that one, right? It's very one of the easiest, mechanism, right, that we talked about till now, right? Chalo. So what about the applications, right? The applications of this, Claisen-Schmidt. Okay. So this is all about now.